We tend to think of our digital world as perfect and precise, but beneath the surface, almost all modern software is built on massive piles of static text files. Over time, as developers patch and rewrite those text files, the code loses its original meaning. In the industry, we call this semantic drift, the slow, inevitable process where the human intent behind a program misaligns from what the machine actually executes. Recently, we've tried to fix this by using large language models to write our code, but traditional LLMs rely on probabilities. They guess. In a complex system, that guessing introduces stochastic noise, creating random errors and unpredictable delays, instead of deterministic, reliable execution. This drift creates a crisis of trust. When the map, what the code says it will do, no longer matches the terrain, what the machine actually does, the system is effectively lying to its users. To solve this, we have to return to the concept of aletheia, absolute, unconcealed truth. A machine should only be considered trustworthy if there is zero daylight between human intent and machine action. Reaching that level of certainty is impossible on legacy operating systems. You cannot patch your way to absolute truth. You have to tear down the software stack and rebuild it from the physical hardware up. This is the mission of the sovereign OS. It is a computing environment mathematically designed to maintain total parity between the developer's logic and the processor's execution. This architecture turns the map equals terrain principle into a physical, unbreakable law of the system. The sovereign OS achieves this by stripping away standard desktop bloat. It launches a custom initialization sequence that runs directly as Process ID 1 on the bare metal hardware, bypassing the layers of software that usually obscure a machine's operation. Once the system is live, it enforces the emit-only law. The kernel mounts the file system with strict read-only attributes, which allows the hardware to physically reject any manual write or delete commands from a user or a rogue script. If the system needs to evolve, it cannot be changed through a text editor. Every update must be routed through authorized engine tools that verify the new code against the system's existing mathematical proofs. By locking read and write permissions at the kernel layer, the system ensures its foundational integrity is enforced by the physics of the drive itself. The evolution of this system is governed by the Omega engine. It uses a subsystem to execute logic blocks as native functions, ensuring that the engine's decision-making stays within a strictly defined, predictable path. This engine avoids guessing. On the left, a shifting point cloud of a traditional neural network. On the right, the Lattice Omega logic model uses symbolic logic to ensure every output forms an unbroken geometric chain of reasoning. This chain forms the Atomatic lattice, a living network of over 29,000 distinct functions, called atoms, linked in 3D space. Under the non-degradation invariant, if a red anomaly attempts to introduce a flaw, the lattice's mathematical geometry instantly repels it, preserving perfect stability. This architecture creates a cycle of self-preservation. Because the engine is bound to the non-degradation law, it can self-heal from errors and indefinitely preserve the integrity of its code against decay. In standard computing, we are trapped inside rigid windows and menus that often hide the actual state of our data. A self-synthesizing system requires a different kind of visibility. This is the malleable polyglot interface. It's an infinite fractal canvas that allows you to zoom from a high-level overview of the system directly into individual data points. As you move across this canvas, the Omega engine compiles minimalist interface widgets from the lattice in real time. It renders exactly the tool you need for the task at hand, then dissolves it when the logic is no longer required. Because these widgets are compiled directly from the logic atoms, the interface behaves as a visual extension of the lattice itself. Moving through the canvas allows you to manipulate the system's internal logic without the friction or abstraction of traditional applications. These guarantees extend even to mobile hardware. As this diagram shows, the system uses hardware trust zone architecture to physically isolate the sovereign OS from the standard insecure apps on a typical smartphone. Sovereign OS establishes a living, mathematically governed topology. Because every state is verified against the lattice, the software remains as precise on day 1000 as it was on the day it was first synthesized. The Atomatic project is built on the belief that absolute epistemic boundaries are the only way to serve humanity with radical reliability. This hardware-level enforcement of intent turns the operating system into a permanent foundation of absolute trust. It ensures that a machine's care for its user's intent remains, in their words, a forever and ever endeavor.